Alright, this is Notes, Chapter 1, Section 2. We're going to do the first 3 pages of the notes. A linear equation in one variable x is an equation that can be written in the form ax plus b equals 0, where a and b are real numbers, and of course a, the leading coefficient, cannot be 0. So, solving a linear equation. This is a review. Alg 1, Alg 2. You've done these equation solving topics already. You first have to simplify each side of the equation. So simplify the expression on each side of the equal sign. You must make sure you remove grouping symbols. And also combine like terms. You're going to collect variable terms on one side. And the constant terms on the other side. In order to do this, you use opposite operations. To go to the opposite side, you use an opposite operation. You then isolate the variable, usually by division, sometimes by multiplying by the reciprocal, but you isolate the variable and solve. Now remember, an equation is not solved for a variable if the variable is on both sides. So in other words, you can't say y equals something times y. Okay, you've got to get them on the same side. And then finally, the most important thing, which most students hate to do, and I will require it on test or quiz, is that you check your solutions in the original equation. Not the shortened version of the equation, but in the actual original equation. Solve and check the linear equation. Now here, this is not complete. I have the left side of the equation. I need to give the right side of the equation. So the right side of the equation is 3 times the quantity 2x minus 5. Okay, so that's a full and complete equation. Now what do we have to do? We have to remove grouping symbols. So I'm going to use distributive property on both sides. 4 times 2 is 8. Don't forget about x. It's positive. 4 times 1 is 4. Positive. And I've got this subtract 29 equals distribute on the right. 3 times 2, 6. Don't forget about x. 3 times 5, 15. It's negative. Combine like terms on the same side. I've got constants here. So this gives me 8x. Subtract 25 equals 6x. Subtract 15. Combine our constant terms. So I'm going to take 25 over here by addition, and I'm going to take 6x over here by subtraction. Okay, those are opposite operations. The opposite of positive is negative. The opposite of negative is positive. I like to do 2 steps in one. So I have 8x's, subtract 6x's, leaves me with 2x's. Negative 15 plus 25 is positive 10. And now I'm going to divide because the opposite operation of multiplication is division. So divide both sides by what's in front of x. And I end up with a proposed solution of x equals 5. Now, I do need to check this in the original equation. So, on a test or a quiz showing me the check, all you have to do is show me the setup and verify that the left and the right sides are equal. I don't need you to go through the process of, breaking it down and showing me step by step by step what it equals. I'm going to copy the template. 4 times 2, there's my space for x, plus 1, close parentheses, subtract 29, equals 3 parenthesis, 2 parenthesis, minus 5. And now I'm going to substitute my proposed solution. Now this part you can do on the calculator, and if you set up using the template with all of the parentheses, it's really nice and easy to just type in exactly what you see. 4 parenthesis, 2 parenthesis, 5, close it, add 1, close it, subtract 29. And I get 15. This is me verifying it. 15 equals, all right, I'm going to do 3 parenthesis, 2 parenthesis, 5, close it, subtract 5, close it. And I get 15. I have verified the check, and I can now be 100% certain that my value of 5 is a solution. Because of the check, I can say my solution is 5. You must use set notation, okay? On a test or quiz, if you tell me x equals, I'm going to take points off, because in the college algebra textbook, we really need to get a hold on the symbolic notation. So writing it as this means the set of all x that makes the equation true is when x is 5 and only 5. Okay, so you will write all solutions in set notation. Okay, all of your solutions must be in set notation. That's the college algebra part of it. This part of solving is not new. The checking is not new. And so just be sure that you put all of your solutions in set notation. Now we can verify solutions on the graphing calculator. I'm not going to do too much with this. I mean, if you want, you can copy mine. It says graph each side as one equation on the graphing calculator. The solution is the x-coordinate of the intersection of the two lines. The solution is the x-coordinate of the intersection of the two lines. I'm going to model this on the graphing calculator so you can see it. And then here, the check value is the y-coordinate. Okay, and I'll show you that if I put the left side of the equation into the graphing calculator as one equation, the right side into the other, the point where the two lines intersect, and that's what this is on the calculator, those two lines will intersect at the point 515. Here's my solution, x is 5, and here's the value of my check, 15. Okay, 515. So if you want, pause the video if you didn't get to write all of this down yet. And I'm going to go ahead and start putting this on the graphing calculator. So again, if you didn't get to write it all down, pause the video so you can copy it. Okay, so I'm going to go into my y equals and clear out of there whatever's in there. And I'm going to type in 4 times the quantity, 2x plus 1, close the quantity, subtract 29. That's the left side. The right side is 3 times the quantity, 2x, subtract 5, close it. Now I'm going to hit graph. Now remember, if I can't see everything on my graph, then I have to change the window. And I might want to change the window. I might want to see what's going on here better. So maybe I'm going to go from 0 to 10 and 0 to 10 on x and y. So I just want to see quadrant 1. So I'm going to go window, x min is 0 to 10, 0 to 10, and I'm going to go by ones. I'm going to hit the graph so I can see what's going on in quadrant 1. It's up there too high. And take notice that my y value is expected to be 15. So maybe I want to change that to 20. So window, Y max, I'm going to say, make that 20. Better yet, make it 25. And now I can see the intersection a little bit better. It's still a little bit difficult to see, but that's okay, because I can have the calculator verify for me in trace mode. You see this button here? It says trace. When you're in trace mode, I can simply just type in, oh, look at that. It's telling me x is 5 and y is 15. But let's just say it came up like this. I could type in an x value of 5 when I am in trace mode. And it's going to show me a 5 down here. And when I hit enter, it's going to give me the y value, 15. And that's the intersection point right there. I could do second calc, intersection number 5. And it's just asking me first curve, second curve. Now, if my cursor was way down here, I would want to move it up as close to the intersection as possible and hit enter, not once, not twice, but 3 times, and bam, there it is. It tells me that they intersect at 5:15. So this is the solution to the equation, and that's where they intersect. So another take on checking your work if you would have time. Alright, so the takeaway here, not so much on the equation solving part because you've done that, but all solutions need to be in set notation. S for solution, S for set notation. Okay, S for solution, S for set notation. Lots of students forget it and then they lose silly points because they're not doing it. All right, side 2. I have to finish my equation here. Example B is 5x, subtract the quantity 2x, subtract 10 equals 35. So I'm looking for a value of x that would make this be 35. I'm going to distribute the negative, right, because this is really a negative 1. So I've got 5x, subtract 2x, add 10 equals 35. Combine like terms on the same side. This is 3x. I'm going to take this over right away to save myself a step. Equals 35 subtract 10 is 25. Divide by 3. X is 25 divided by 3. Folks, I'm not interested in decimals. No decimals. I want the exact answers. Okay? I'm going to set up my check. All right. So 5 parenthesis for x, subtract parenthesis 2 parenthesis for x, subtract 10. Does that equal 35? My fraction is 25 thirds. See, if you get the decimal and you put it in here and you're rounding, it's not going to give you an exact 35. All right, so I'm wondering if 25 thirds is going to make this equal 35. So 5 parenthesis 25 divided by 3, close it, subtract parenthesis 2 parenthesis 25 divided by 3, close it, subtract 10, close it, hit equals 35. It does work. 35 equals 35. Check. Therefore, I conclude my solution is 25 thirds. Now, I could graph this to check it. I'm going to clear all that out of there. 5x, subtract quantity, 2x, subtract 10, close it. Second equation is 35. Now notice, this is a y equals 35, so I have to change my window. I'm going to graph it. You're going to see that I'm not going to be able to see both lines. So I'm going to change my window. I'm going to go back, negative 10 to 10 on x. The y, I'm going to go, I don't know, negative 10 to, let's say, 50. And I'm going to hit graph. there we go, and I can clearly see the intersection. I can go into trace mode, and I could type in my x value of 25/3, 25 divided by 3, and it's telling me the y is 35 right away. So I have convinced myself that yes, this 25/3 is a solution to this equation. The next one, this is a long one, and I'm sure you're going to find one like this on your test or quiz because it's long. I would do what's inside the first grouping. So I've got a 45 subtract. Now normally what I do is have students do this in class, and then we compare our answers and see if they got the right answer. If you would like to do that, you can pause the video and try this one on your own. How about this? I'm going to pause the video and work out this problem, and then you do it on your own and see if we get the same answer. Okay, hopefully you pause the video and work this problem out yourself. And had you done that, you should have gotten a potential solution of y equals negative 81 over 11. You then probably should have went in and done the check right away like I did. Oh, well, let's go back up here. You've got to make sure that you are getting rid of grouping symbols that are inside grouping symbols first, like here, and like here, and here. So I went through that process. And then before distributing a negative to all of those terms, I like to combine what's inside there first in that grouping. Makes it easier that I don't make as many mistakes with distributing a negative sign. And I end up with this piece right here, this step of the equation. Now I have like terms on both sides of the equation, so I'm going to combine those first. And then over here I've got y's and constants, so I combine those and get this statement here. And then what I ended up doing was taking this over and taking this over at the same time to get 11y equals negative 81 and y equals negative 81 over 11. Now this is the exact answer. If you typed that in the calculator, I'm not sure what you're going to get, but I will do that in a moment after I show you my check. So I ran out of room on my paper for doing the check, so I had to bump down here. But this is the left side. And it was really nice because I was able to use all the parentheses that I wrote down to type it into the calculator to keep myself organized. And, you know, the rest of this is above on the calculator, and unfortunately I can't move it up to show you the top of the screen. But I put the whole left side in, and I ended up with 24.81818182. Okay, so this looks like 24.81 repeating. And then the right side gave me the same exact result. Now I can change this to a fraction if I want to, which would be beneficial for you if you don't know how to do it. All you do is hit the math button one time and then hit enter twice. Enter, enter. And so my fraction there is 273 over 11. So 273 over 11 does in fact equal 273 over 11. I can be sure now that my solution is negative 81 over 11. Okay, remember all answers need to be in set notation and in fraction form. Now if I type negative 81 over 11, I get this decimal. Okay, well, math enter, enter fixes that for me. Now if you ever do math enter, enter and it does not convert it back to a fraction, it means then that the number you're working with is an irrational number. And remember, irrational numbers cannot be written as the ratio of two integers. This decimal can be written as the ratio of the integer negative 81 divided by the other integer 11. Okay, so if you ever try math enter, enter and it does not give you a fraction, it means it's an irrational number. Okay, so if you have questions on any of this, post a comment on the homework discussion or ask me in class. We have one more page of notes to do, and then we'll be done with this video. All right, solving a linear equation involving fractions. This is like our rational expressions. Okay, and we had that lesson in Chapter P, Section 6, of simplifying and getting a common denominator. So in order to level this off and get rid of denominators, all you simply do is multiply each side of the equation by that least common denominator. Okay, so I look here at my fractions, and I see the denominators are 4, 3, and 6. So I want the smallest number that 4, 3, and 6 are going to divide. So I'm going to build my common denominator. I need the 4. I need the 3 because that's different. 6 is not 4 or 3, but if I break 6 down, this is 2 times 3. And you sure bet that this 4 has a 2 in it. You know, I could think of this as 2 times 2. This is just 3, and this is 2 times 3. And if I wanted to write the LCD better, I need everything in the first denominator, even if it's repeated. And then each thing in every other denominator that's different. A 3 is different. A 2, it's already in there. A 3, it's already in there. And so my least common denominator is 4 times 3, or 12. Okay, so I'm going to arrow over here to the right for my workspace. I'm going to copy the original problem down. X over 4 equals 2x divided by 3 plus 5 over 6. And I have to multiply each side of the equation by the LCD, and the LCD is 12, or 12 over 1. You could write it as 12 over 1 so that you see fractions across the whole way. Now, if you're slick, you would know that you'd multiply the 12 with the x, the 1 with the 4, and then divide. Or you can simplify right now. You know, 4 divides 12 3 times, and 3 times x is 3x. This is already a 1, so the 12 is going to absorb the 4 3 times, and then 3 times x is 3x. On the right side, the 12 is going to absorb the 3 4 times, right? The 1 is simply 1, doesn't really matter. The 3 is going to get absorbed into the 12 4 times, and now I have 4 times 2x, which is 8x. You can't forget to distribute this because you have 2 fractions here. Okay, now pretend that's not there and just work with 12 over 1 times 5 over 6. The 12 is going to absorb the 6 2 times, and 2 times 5 is 10. So this is plus 10. Take this to the other side by subtraction. This is negative 5x equals 10. Divide, x equals negative 2. Check. In the original, negative 2 over 4 equals 2 times negative 2 over 3 plus 5 over 6. Now, when you check these, because they're fractions, you need to put parentheses around your fractions. Excuse me. You have to tell the calculator, because the calculator isn't smart enough to say, hey, wait a minute, you're not doing something right. Okay, so I'm going to quickly type this into the calculator, parenthesis, negative 2, close it. I know you can do this in your head, and sometimes it's easier, quite frankly, to just do it in your head, but I'm going to show you with the parentheses on the calculator. All right, that's negative 0.5. Makes sense. 2 over 4 is a half, and make it negative is negative a half. Equals, all right, on the right side, clear, parenthesis, 2, parenthesis, negative 2, close it, divide by 3. Actually, I might run into a problem here, I'm not quite sure, because I really should group this product. Sometimes you do run into an issue there, so let's do that over. Parenthesis, 2, parenthesis, negative 2, close it, divide by 3, close it. Hit equals. Do add, parenthesis, 5 divided by 6, close it, hit equals. Oh, there it is, negative a half. Now, sometimes students ask me, well, if it doesn't equal, how do you know if it's right or if it's wrong? So, I don't know. Try typing it in again. Try doing the graphing one side and seeing if they intersect there. Alright, since the check does work, I can confirm that my solution is in fact negative 2. And I write my answer in set notation. One more problem to do. You could, if you wanted to, pause the video and try this one on your own. Let's do that. I will pause my video. Okay, hopefully you worked through that problem. You ended up with x equals negative 19. Folks, I highly recommend that when you have quantities in the numerator that you come over here and write your work as though it is a quantity. That way, you see, when the 24 absorbs the 3 and becomes an 8, you actually have 8 times the quantity x minus 2. And putting the parentheses there is an indication that you have to distribute. Same thing here. When the 24 absorbs the 8 and becomes a 3, I end up with 3 times the quantity x plus 3. Then we go ahead and use the distributive property, combining like terms on the same side and then on opposite sides, and finally dividing x is equal to negative 19. I set up my check and I use that same rationale with the quantity, okay, and then the parenthesis for the x. And when I went ahead and typed in exactly what I see, you know, here I have 5, there's my 5 plus, and then I had 1, 2, 3 parentheses, negative 19, close a parenthesis, minus 2, close a parenthesis, divide by 3, and then close it. Negative 2 does in fact equal negative 2, and so I can be sure that my proposed solution of x equals 19 is an actual solution, and then I put it in set notation. So again, if you have any questions as you're working through this, leave me a comment on the homework discussion or ask me in class. Have a great day.